Sub. Hello and welcome back to Calculus 1. This is our last section on 5.5, new substitution. It's going to be a part 1 of the lecture, and then the next week part 2. We really need to understand this because the Calc2 survival right, depends on this lecture. So we start by understanding that we can integrate x plus 3 easily. We should be able to. This will be, part of your next exam. Integrating x, you are getting what? Exactly. And then plus what?
C.
Hold on. Integral of 3 is 3x and then plus c. So for this particular integration, we use the formula, which was x to the n plus 1 over n plus 1 plus c. So this was something that we did in 4.9. We haven't learned anything new now. Also in 4.9, we had a problem similar to this, when this was squared. And the way we dealt with it is we said, well, FOIL it, and then integrate each one separately. So we had x squared plus 6x plus 9 dx. And then when we integrate x squared, we go plus 1, right? So x cubed over 3, plus 6 times x squared over 2, plus 9x, plus c at the end. So you either have limits, and you get a number at the end, or you don't have limits, and you get plus c. 6 and 2 will cancel to 3, right? So we are able to do the basic integral up there, and even if we have an exponent there, you FOIL it, right? But now we get to the question x plus 3 raised to the power of 39 dx. And I'm saying, all right, go FOIL this. I'll be back next week. Yes.
No, x plus 3 is just going to do now. Do that?
Yes.
Okay.
So instead of FOILing this, right, multiplying the 39 of these together and spending wasting considerable amount of time, we employ this new technique which is called u sub. The logic and thinking goes this way. This would be so much easier if all of this was just one thing. If this was just x to the 39, this problem is so simple. But it's not x to the 39. So you know what I'm going to do? I'm going to make it to be by saying, you know what? I'm going to define this x plus 3 as new variable u. You're allowed to do that. And now this integral becomes integral of u to the 39. But see, you can't put dx, right? Because now your integral needs to be in terms of u, not in terms of x. So you have to also transform the other part, and that is going to be you taking the derivative of whatever formula you came up with here. So now you have the du dx is equal to 1. And you move dx to the other side. So du actually equals dx. And that's how we transform our integral completely from something that would take a very long time, it's really annoying to multiply that 39 times, into a problem that we can solve by simply adding 1. So u to the 40 over 40 plus c. Now we can't leave answer this way. because the problem was posed in terms of x. And what you have there is u. So you have to go back to the x variable. There is a simple sentence that you can quickly say in your head, and it immediately clicks. You say, I don't care about you, I care about the x. So you quickly, right? I don't care about you, I care about the x. Just be careful where you use it, though. So,
I got it.
I can't really, I've never said that in my life.
So now, we have 1 over 40, and then u is x plus 3 raised to the 40 and plus c. Now that the problem is done. Right? The solution is given in x value. Now this means that if you were to sit there for a day or so and FOIL that 39 exponents, integrate the monstrosity you get, you would be able to actually condense that into the answer you have back. Now, the U substitution method, which is the stuff written in blue, helps us do that in 2 lines rather than in 2 days. And maybe the notebook of 80 pages. Let's take a look at another example of this. Hopefully you remember that we said that the integral of e to the ax dx was e to the ax over a plus c. You were supposed to memorize that in 4.9. So you know that the integral of e to the 3x dx is e to the 3x over 3 plus c. But since I listen to this all day long in my house, I'm going to exercise the same. Why? And I love that question because I get to talk about it. So here is why. When we have integral of e to the 3x dx, you immediately go and say, ugh, if this was just one thing, it would be so much easier to integrate. You see, every time you have this U substitution problem, it starts with that attitude. Ugh, if this was just, better this way, it would be easier to solve. So we immediately know that U equals 3x because that's where the happened. The attitude, right? So now I have my derivative that I need to take. Du is going to be 3. And we can immediately put dx on the other side because, du over dx gets shipped to the right side. Great. We have our substitution pair. We have something to replace for 3x and something to replace for dx. So let's just plug them in. Integral of e to the u. And I hope you see that instead of dx, I get to plug in du over 3, right? Well, that du over 3 is going to kick that 1/3 in front of the integral. And look what we have. It's just e to the u du. Well, that's a joke. The integral of e to the x is e to the x plus c. So integral of e to the u is itself e to the u plus c. I don't care about u, care about the x, so there we go. Plus c, and we have our solution. U substitution method is supposed to take something that is complicated or can't be done and transform that integral into something that is on the list of your basic integrals. Where are the basic integrals? In 4.9. So clearly, if you don't know 4.9, if you don't know what the basic integrals would look like, then you will have horrible time solving these problems, because you pick what goes for u sub. It's not prescribed, it's not given. You look at the problem and you say, okay, so this is the way I do it. Now you see that the answer that you were supposed to memorize before and the answer we got is the same answer. Let's step it up a bit. Integral of x square root of x squared plus 3, let's do plus 6. I use 3 too much. Dx. There is nothing you can do about this problem. You can't FOIL it. You can't distribute. You can't get rid of the square root. You can't separate x squared plus 6. There's absolutely nothing you can do other than using the attitude and saying, yeah, if this square root was just, one thing. So you say u equals x squared plus 6. Because then you're going to have square root of u. And square root of u is a basic integral, because square root of u is written as u to the 1/2. So you will be using xn plus 1 over n plus 1, right? It's just exponent. Easy. So your job is to find a way to get the easy stuff that you can solve with easy formulas from 4.9. Now let's see what happens when I do the du part. What's the derivative of 2x? I mean of x squared? Damn it. It's 2x. And then I have to put the dx, right? That would move over. Right? Guys, u prime is du over dx, right? So this was supposed to say du over dx, but I shipped that dx to the other side immediately. Now let's look at some of these comparisons here. I'm green. Let's go with purple. Fine. Please note that over here you have x dx, and over here you have x dx. You can't really see the purple, right? Let's use the orange. Complementary color to blue. Here's your x dx. And here's your x dx. So now, this is integral square root of u du over 2. The 2 goes on the other side because I already have x dx in the integral right here. X dx. So that's this much. This 2 is extra. Move it to the other side. So x dx is equal to du over 2. So x dx is equal to du over 2. And you have root of u. You sign x squared plus 6 to be u. Hey, we keep this half in front of the integral and just deal with this, the very basic. So I have 1/2 integral u to the half du. 1/2, add 1. U to the 3/2 over 3/2 plus c. Half and a 2 will cancel over here. So we have 1/3 times x squared plus 6 to the 3/2 plus c. Hello, Calc2, right? Almost every problem of Calc2 that is integration will be this, in some sense. You know what? This is good. Is this answer correct? If your answer is I don't care, I can't really battle that one. But if you do care, we're going to check by simply taking the derivative of that answer of 1/3 x squared plus 6 raised to the 3/2 plus c. I must get this. If I get anything else but that, we have to repeat the problem. So let's talk about derivative. Well, derivative of plus c is 0, so we don't care about that. When I take in derivative here, I copy the constant, that's 1/3. Then I have to take the derivative of the parenthesis part with the exponent, so drop the exponent down. Copy this to -1, that's going to be 1/2, times the derivative of the inside, which is 2x. There's a chain. There will always be a chain, because I did tell you already that, not in the lecture but before we started this, that the U substitution is backwards chain rule. So every time when you're checking these problems, you better have a chain rule when you do the derivative. So 3 cancels 3, 2 cancels 2, and there it is, x square root of x squared plus 6, right? 1/2 is the square root. This solution is good, right? We move on with our life. So for each of these problems so far, we looked for a way to make the problem simpler by uniting this into a single variable so that we can deal with u to the 39 rather than x plus 3 to the 39. Over here, even though we did memorize this before and we know how to solve it, now we know why that works. And finally, our problem here that had some extra well, no, there was nothing extra here. It's fine. Let's take a look now at another problem. Which says integral of sine to the 10 x cosine x dx. Now this is where things start being interesting. What do you pick as u? You have many options here, right? What do you pick as u? Well, I haven't still told you the biggest and the mightiest tool that you can use to figure it out. I'm going to write it in blood. Function, derivative, pair. Your function will be equal to u. Derivative will go to du eventually. So what is the function? What is the derivative? Yes, sine and cosine. So we can kind of see three different things going over here. We have a function sine x, we have a function cosine x, and we have a function x to the 10. Right? Sine to the 10? Yeah, but if you are doing the function decomposition, right, it will be x to the 10 and then you plug sine in. So one of this from the list is going to be your u. Which one? The one that has its derivative present. That immediately eliminates x to the 10, because x to the 9 is not present. See that? So now I will go with u equals sine x, because the du is going to be cosine x dx. This skill will take time to develop, so please practice it. So now my sine is u, I get u to the 10, and a cosine dx entire thing is just du. We converted a trigonometric integral into a polynomial. U to 11 over 11 plus c. 1 over 11 sine to 11x plus c. As you can see, the purpose of the u sub is to make a joke out of these problems.
Could you have done it using cosine?
Yes. Oh no, because sine was raised to the 10. If you have just sine times cosine, yes.
Okay.
But because sine had a 10 on it, you can't. Maybe you have cosine squared and then sine without it. So whichever one had no exponent is left for du, obviously. Right, and the other one is the main function. Because sine is the derivative of cosine, cosine is the derivative of sine. Just the way it goes. We'll do one more problem, and then we'll do the review. Yes?
You have a word problem example?
No. Sorry to disappoint.
Yeah, but
I'm not, but such life. All right, we can't always have what we want.
it's probably going to test studies anyway.
Unless you want me to come up with something specially for you for the exam, I can come. I'll dust off some old books.
That... just for the class, man.
So now, I would like to take a look at integral of x to the 9 cosine x to the 10 dx. This problem is different than the previous one. What is your u now? So what is our u? Is there a sign to be its pair?
Well, there's back to no,
X to the 10. U equals x to the 10. Okay, so start there. Okay, so you already discovered that u is equal x to the 10, which means that du is 10 x to the 9 dx. Great. I have everything except this 10, which we move to the other side, right? Because x to the 9 dx is already in my formula here, in my integral. So I will have, instead of cosine x to the 10, I'll just have cosine u, and then I'll have du divided by 10, because x to the 9 dx is equal to du over 10. So this is 1 over 10 integral of cosine u du. What's the cosine of u integral? Sine u plus c. I don't care about u, I care about the x, so it goes sine x to the 10 plus c. If I had that button that says ta-da, I'll do it. Actually, I can play it on cell phone. Is this lecture over? No. We are going to have some more interesting examples, and then we are going to do the same thing for definite integrals, where you will have to not just do the u sub, but you will also have to swap the limits. And that's going to be part 2 next week. Bye.